Good morning. This morning I'm going to be using the tablets that the GDE has supplied to most of the schools to do a bit of a classic science experiment. We're going to use this to actually do some motion analysis. Where in the past one would have used ticker tape and ticker timers, I know that can be quite intimidating sometimes. These tablets actually allow you to do the same experiment with a relatively good degree of accuracy. All you really need is the video camera, which is part of the tablet already, and you're going to need to set up your own track. What I've got here is I've basically got a Lego track. You can use other things as well, and very importantly I've got a clear plastic ruler, so that when the video is being taken I can actually stop it where I need to and see how far the object has moved in a certain amount of time. But more about that later. How do we actually do the recording of the motion? You get yourself a retort stand and a retort ring, and you put your tablet on top there like that. The idea here is to try and get the whole 50 centimeters of the ruler into the picture. So what I'll do is I'll move this around a bit. Wrong way around. And over here I have now got the entire 50 centimeters of this tablet as view, and I'm ready to start the experiment. I've got this on video recording. So what we're going to do now is we're going to take an object, a bit of a Lego train base, and I'm going to push record, and I'm simply going to let the object run down the track. One can let this happen a couple of times. So let's do a new recording. Stop. Let's start again. Marvelous. So there I've got my recording. Like I said, I made use of Lego in this example. Other objects that work really well that I've used in the past while preparing for this is a bit of conduit and a toy car. This works just as well. The secret is, however, to get this next to the ruler. You will see later when we look at the video footage, it's very important that one is able to determine the position of the vehicle. So what we're going to do now is we're going to go to the front of my class, and I'm going to show you then how we're going to analyze the video. Thank you.
Okay, so here's a view of the tablet. We're going to go now to the gallery. That's the icon there next to camera, and once I've selected that, I will want to navigate my way to videos, not so much the screenshots just yet. Select the video, and this is the one that we're going to be using for our experiment, and now I'm going to press play. And you will notice immediately I get three options. Two are built into Android, into this tablet anyway. The one is the movies and the other one is the photo app. But I downloaded from the Google App Store, free of charge, a app called Easy Slow Motion. Works marvelously. If I select this app now, you will see what it allows you to do. It allows you actually to push frame by frame. So this advances frame by frame, and then for each frame, of course, if you look in the top left corner, you'll see there's a time indicated, and I think it's actually clear that you can see the ruler is going to help us quite a bit here in determining position. It's very clear to see, which is why I prefer the clear ruler in this case. Right, screenshots are taken, and it's these screenshots next that we're going to be using. I did this experiment with a little orange toy car, like I said in the beginning, on some conduit, but I prefer this experiment I did last with the clear plastic ruler. The numbers are just so much easier to read. Here I've got a screenshot. Lovely. I can manipulate the picture, well, for my needs. Zooming in and out is extremely important. It allows me to get really, really close to the ruler so I can note the position of the object. I can also then make a note of the time for that object, and that's all one really needs to determine a velocity. Is a position and a time and a change in both. So let's switch off here and get ready to start the next section.
Okay, now let's go and analyze the footage we've got. The software I used to create these screenshots, I will give you at the end of this show. But what's important is, in my picture here, the screenshots which I have taken of my video's motion, The screenshots there include a timestamp. In this case, I can quite clearly read 0.303 seconds. And of course, I can see quite clearly on my trolley over here, from here, without even enlarging, I can see we're there at 5.7 millimeters. But now this is the nice thing about having these screenshots. They're effectively timestamps with an image. You can zoom it. With other words, even on the tablet, it works absolutely amazingly. On the tablet, I can see that the actual reading there is 5.77 millimeters. With other words, my first displacement, my first position is 5.7 millimeters. Now let's just convert that to meters straight off the bat. That's 0.0057 meters. That is my x1, my position 1. And the time over there, if we zoom out, I can see was 0.30 seconds. With other words, my first time is 0.303 seconds. What is important now is when we progress to the next slide or next screenshot, it doesn't have to be the very next one. We can actually progress 2 or 3 screenshots further. And I'm not going to do that. I'm going to say, right, there's a screenshot. There's another screenshot. Okay, let's take one back. I'm going to work to this screenshot. That will be the next one I'm going to use. Once again, I can see the time quite clearly. Now I would like to actually go and find my position again. So once again, all I do is I zoom. Like I said, it works like a charm on our tablets as well. And wow, this thing is extremely clear.
Good morning. We're back. This time from the whiteboard, rather to the computer screen where I've gone and summarized the information for you. This is my interval A. It's the first screenshot and the second screenshot, and I'm going to use this information to go and calculate an average velocity. As indicated earlier on the whiteboard, the displacements are read off the ruler, and then the times are given in the top left corner of each frame. So what I'm going to do is, once again, I'm going to take this information, but this time I've gone and prepared a spreadsheet. It just works so much better, and I'm going to put the information in there. In other words, for my interval A, my first position was 57 meters, and the time was 0.303 seconds. My second position, or position 2, was 113 millimeters, and the time that I had there was 0.436 seconds. So by entering that information, this automatically calculates our answer for us. I get an answer here of 0.421 meters per second. So here's the data that I took off the screenshots. Don't forget, we've got to convert to meters. We are calculating the velocity. Once again, I stress average velocity. We'll talk about that a little bit more later. Right. Let's go and look at my second interval. What we're going to do is we're going to see the information there, and we're going to carry that across. So for interval B, I've chosen the second last and the one before that screenshot. So we are going to be looking from this screenshot to that screenshot. The screenshots do not have to be consecutive. There could be 2 or 3 screenshots in between. That doesn't matter. Just make sure that you've got the first and the last in the correct place. So in this one over here for interval B, I went and found my displacement there as 228 millimeters. Like I said, the big advantage of using the tablets is you can really zoom in to get the information that you want, and it makes measuring a little more accurate. Right, the timestamp then for that screenshot, 0.836. For this one over here, we'd already progressed to position 343 millimeters and a time of 1.036. Let's take that back to the calculation page. So the displacement or position I'm using is 228 millimeters. The time 0.836 seconds. My second position was 343 millimeters, and my second time then 1.036 seconds. Great. I'll pop that in there, and once all that data has been captured and converted, I get an answer there of 0.575 meters per second. Now I can clearly see that this velocity is a bit greater than that one. Okay, that's actually good news, because the next thing we want to do is we want to go and calculate an acceleration, obviously. Right, now acceleration is the change in velocity over the change in time, but here there is a bit of a trick. Even with ticker timers and ticker tapes, we were dealing here with average velocities. So in other words, this velocity that you see here is an average velocity between position 1 and position 2, or between time 1 and between time 2. I've got to be very careful that I calculate my time correctly here. What I've tried to do is I've tried to indicate how to do that. If we go and look at our first interval, time 1 was at 3.03 seconds and time 2 at 0.436. I would like to know what the time is in the middle of that interval, because that is the time for velocity 1, which I'm going to use over there. With other words, as we teach our learners, the average velocity is equal to the instantaneous velocity at the middle of that interval. So what is the middle of this interval? Well, to do that, I will say time 2 minus time 1, time 2 minus time 1. I divide that by 2. With other words, I've done that. I've added them to, subtracted them, divided by 2, and I got this value here. And now I've got to add this value to time 1. With other words, from time 1, the 0.303, a further 0.0665 seconds later over there, I've got the time for the middle of my interval, namely the 0.3695 seconds. And you will see that is what I then use for time for velocity 1. For t, v1, I used the 0.3695. In exactly the same fashion, I will go and calculate the time for velocity 2. Right. Now, once the times are in there, they're the tricky bit. The velocities are quite nice. That velocity there, v2, I got from the calculation, and this v1, and velocity 2 over here, I got from this calculation. That's actually the easy bit. Nice thing is I've now got an acceleration, and this acceleration then is the answer that I've been looking for, and it's a positive acceleration, so yes, indeed, the trolley was indeed speeding up.